Hello everyone, day 2 on limits from a graph. Some of them are real basic, and even on the AP test you get some real basic ones. But then every once in a while there's these difficult problems, and that's when you want to remember that a limit is when there's a left side limit exists, a right side limit exists, and they're equal to each other. This looks like just practicing the basics here, and sometimes these basic ones you don't have to focus too much on the definition, but we'll see. All right, at -2, just your real basic, whatever that point is, it looks like it's going to be just -1. That's just the y value because it's a continuous function. Here at -3.5, all right, there's a hole there, but that doesn't matter. You don't care about the hole, you care about the neighborhood, and so I think that's just going to be 0.5. How about at -1? This is an example where a limit does not exist because the left side is down here, the right side is up here, and they don't equal each other. At 3, once again, you never care about the point itself, and so the limit's just going to be 1. At -infinity, there is an arrow, so the y value is going to be going up to infinity as the x value goes to -infinity. And at infinity, same, it's going to be going up here. So just your basics. Here's an example of a problem where it does get tricky, and a lot of people are going to say not existent here, and that's give you a little preview. That's not going to be the right answer. What is bad thinking? Here, bad thinking is, well, if I plug in 0, I care about f of 1, and I see at 1 there's a gap here, non-existent. Way to using a shortcut that does not work here. What happens here? On the left hand of 0, and that means x is less than 0, we're looking at f of, all right, if x is less than 0, that's things like -0.001. And when you square this, you get a positive number. So you get 1 minus 0.0001. So we're looking at f of 0.999. And f of 0.999 looks like it's going to be at 3. Whereas if I'm at x equals 0.001, right, the right side of 0, when you square that, it's still positive, and you're still going to be looking at 1 minus 0.00 something. You're still going to be at f of 0.99, or 0.99999, whatever you want to think about. And that's going to be equal to 3 again, and so this one does come out to be 3. Just some basic practice with composite functions. This looks like the f graph, and this looks like the g graph, and sometimes you can just use shortcuts here, sometimes you can't. You have to just get good at knowing when it's a difficult problem. All right, g of -3. All right, at -3, oh, this is the g function here. So we're talking about right around here, nothing tricky, it's a continuous function. So that's going to be -1. So we're going to use a shortcut here because I think it's going to work here. And f at -1 is at, -1 is here, up 1. That's going to equal 1. So nothing tricky there. This is just focusing on asymptotes, making sure. Now I tried to include the function because I have, we'll get into these when we start doing other limits. At -3, I see that this is going to flip-flop between positive and negative. So I bet you this does not exist. So let's see what it looks like here. Yeah, this is going to be does not exist because on the left side it goes to -infinity, on the right side it goes to +infinity. Whereas at x equals 1, when I plug that in, that term, or that factor, I really should say, is going to be positive no matter what. So we will get an answer here, and that answer is going to be infinity. All right, video is still short enough that I think I'll go straight to the next page. All right, the most common mistake here. Let's see. At x equals 2, what do I know at x equals 2? Well, the value is 1, but more importantly, I notice it's going to be 0.999 below and 1.001 above, but it never gets to the 1.01. This function is always less than 1. So I'm going to think of f of 0.999. And what do I know about f of 0.999? It's down here at 2. Notice I don't care about the actual point. I care about the neighborhood. And here, notice that the only value that y takes on are values less than 1. And that's why you can get an answer here. How about when I plug in -2? Here's another case where at -2, right, this function is never near -2. We're at -0.001 and 0.001. We never get there, right? So if I'm focusing in on here, I notice that this function is always below 0. And so now I can look at f of -0.001, and that's going to be here at -1, right? Some people, want to take your time and think of the left side and the right side. When I plug in -2 on the left side, I'm going to get f of -0.01. And then when I do it on the right, I'm also going to get f of -0.01. And that's why you do get an answer. All right, so just stole this from a book. It looks like just a bunch of just practicing, getting used to. This is f, this is h, this is g is down here. Okay, g is at -2. All right, so f and g near 4. F is at 8. And g is at, well, g is going to be at -2 no matter what. So that's going to add up to 6. How about a number f times something minus? All right, so at 4, what do I know about f at 4? It still limits. We don't want the actual point itself. So we still want 8 here. What is g? G is, well, g is always -2. And h, this time h is at 0, right? Yeah, h is at 0 because we're near 4. Yeah, so 8 times -2 would be -16. So just practice being precise here. F times g. Once again, we're in limits, so we talk about the 8 and we talk about the -2. When you multiply them together, you get -16. How about 2 times h of x? H near 4 is 0. 2 times that is still going to be 0. How about e? G divided by f. We're near 4 still. G is -2. F is, once again, 8. So -1/4. And h divided by f. 0 divided by 8. Right, that's not undefined. That's a number. 0. That's going to be 0. All right, 2 more practice problems. There is more practice on this. If you want this, just come see the teacher. F of 3. We're going to do f of 1.4 plus something. What do I know about f of 3? Well, we don't care about that point. We want 0.001 or something like that. So we're really at f of 1.40001. And now that's somewhere between 1 and 2. And well, we kind of want to know what that line is. That line is, what is that line? That line is y equals x minus 1. So if I'm here at 1.4 and subtract 1, I'm going to be at 0.4. Yeah, I don't see that much, right? Because, I know we use 0.01, but then are infinitely close to that. So the actual answer is 0.4. All right, f and g are shown. What is the value of f of g of 2? you know, and the neighbor. So let's look at g of 2 first. We don't care about that point. We care about this value, which is at 1.001, right? It's definitely above the 1. I don't think that's going to play a role here, though, because f of 1.01 is going to be at 2, and we're going to equal 2. All right, so hopefully if you've gotten this far, there's going to be a lot of good X practice. Bye, everybody.